Now, homogeneous system, as you know, I have told you before that a system in which right hand side is 0, 0, 0, all zeros, then we say that the system is a homogeneous system. And homogeneous system always has a solution which is zero solution. Yani all the variables equal to 0 always satisfy this all these equations. 0 satisfy all these equations without any problem. Always has a solution x1 0, x2 0, xn 0. This solution is called trivial solution, and we are not interested in this trivial solution. And if some or all xi are non-zero, some xi or all xi are non-zero, then the solution is called non-trivial. And these are two results. A homogeneous system like this possesses non-trivial solution if the number of equations is less than number of variables, exactly the situation which I just showed you with the C1, C2, C3. So this is a theorem. So whenever you see a homogeneous system, number of variables is more than number of equations, then at once you should know that this system is consistent. Yani it has solutions and they are non-zero solutions.
Doctor,
Yeah.
how is it possible to solve a system where the variables are more than the equations? Aren't we going to end up with infinitely many solutions?
Yeah. So it is saying what? Possesses non-trivial solutions.
Okay, I got it. Thank you. Could you please, Doctor, flip out the screen because it's not in full?
No. Is it not easy to see like this?
No, it's easy, but it's better if you flip it.
Okay, I thought maybe in this way I can show you more on one page than like this. Because here you see, you are seeing only a little, right? And now you are seeing, you can see in one screen too much. Maybe I need to move screen up or down. So somewhere, for example, okay, let me ask you, can you see the theorems right now?
No.
You can hide the bar above, which has the colors and the draw and the menu. You can hide it.
How can I hide it?
There is an arrow above the screen, the search bar.
There is a
No, and
auto hide ribbon.
yes.
Like this.
Yeah, it's better now.
Yeah, now you can see more. Okay, so one thing we should know that if number of variables is more than number of equations, we have some free variables. Okay, now in case of non-homogeneous system, we may have a situation where there is no solution. Like we have two planes which are parallel. So we have two equations. Two planes mean two equations. They are parallel. Yani not on each other, but above each other. Okay. And they are not intersecting. So we have two equations, three variables, no solution. But if it is a homogeneous system, yes.
Do you writing something? Because we just say the first line of the theorem
Now, do you see it now?
Yes.
I'm not writing anything. I'm just explaining the theorem. A homogeneous system of the form 4 possesses non-trivial solutions if number of equations is less than number of variables. So this is a must. And the next thing is that if you have a solution x1 of a homogeneous system, ax equal to 0, then a constant multiple of a solution is also a solution. If we have two solutions, then sum of those solutions is also a solution. And you remember, I think all of you they have taken Math 202. Am I right? Math 202.
Yes, yes.
And you know
Yes.
that for a differential equation, if y1 of x is a solution, y2 of x is a solution, then c1 y1 plus c2 y2 is the general solution. You write like this.
Yeah, it's not.
So constant multiple of a solution is a solution, and their linear combination is a solution. The same thing is mentioned here. Now, let me go to the exercise and solve some questions. Exercise 8.2. Question number 2. Okay, what is question number 2? Where I can move it down. Come on. I need black color. Question number 2 is 3x1 minus 2x2 equal to 4. 3x1 minus 2x2 is equal to 4. And second equation is x1 minus x2 equal to -2. Now the solution starts here. What I do, I make the augmented matrix. 3, -2 equal 4. 1, -1 equal -2. First thing I need to do is to make leading coefficient in first row equal to 1, and that I can do by interchanging row 1 and row 2. I can divide first row by 3, but that will make things more complicated. So -2, 3, -2, and 4. Now below this leading coefficient in first row, below I need to make zeros. So what do I do? -3 times row 1, add in row 2. -3, 1, -1, and -2. So there will be change in row 2. So row 1 multiply -3. 1 multiply -3 is -3, and then you add in 3, it is 0. -3 multiply -1 is 3. 3 minus 2 is 1 here. And then we multiply first row -2 by -3 is a 6. 6 plus 4 is 10. Now this is echelon form. This is echelon form, and we say it is Gaussian elimination so far. Now if we stop doing row operations here and write the equations from this system, from the last equation we get 0x1 plus x2, 1x2. 0x1 plus 1x2 equal to 10, which means x2 equal to 10. From the first row, we get x1 minus x2 equal to -2. So x1 equal to -2 plus x2. and x2 is 10. So 8. So we get 8 comma 10 as a solution, and you can see it satisfy the both these equations. Or what we can do, we can reduce we can apply more operations to make it reduce echelon form, and that is that add row 2 in row 1. So if I add row 2 in row 1, row 2 will not change, and 0 plus 1 is 1, 1 minus 1 is 0, 10 and 8. Now this gives you this system, and from here we get what system? X1 equal to 8, x2 equal to 10 directly. So 8 and 10 are the solutions of this equation, system of equations. Ask me if any step is not clear. Yeshava.
Clear, doctor.
Now let me do a 3 by 3 question, and that is question number 6. Okay. Let me save my time and write the augmented matrix directly. 1, 2, minus 1, 0. 1, 2, minus 1, 0. Instead of writing line, let me just, or maybe I can write it. Second equation is 2, 1, 2, 9. 2, 1, 2, 9. Third equation is 1 minus 1, 1, 3. 1 minus 1, 1, 3. So this is the augmented matrix. By chance, leading coefficient in first row is 1, no problem. Now we need to make below this zeros. So what row operation should I use? Can someone tell me?
Minus row 1 plus row 3.
Minus 2 row 1 plus row 2.
Also minus 1
Minus row 1 plus
plus
row
R3.
3. So row 1 is being used, so no change there. Minus 2 plus 2, 0. Minus 4 plus 1, minus 3. Minus minus plus, so 2 plus 2, 4. 0, no change here. Negative 1, positive 1, 0. Negative 2, minus 1, negative 3. Negative, negative, positive. Positive 1 plus 1,
0.
2. 0, so no change here. Okay. Now, let us make the leading coefficient row 2 equal to 1. Negative 1 over 3 row 2. And we can multiply any row by a constant. 1, 2, negative 1, 0. 0, 1. Negative 4 over 3. Negative 3. Divide by negative 3. And 0, negative 3, 2, and 3. Now, the leading coefficient in row 2 is 1, and below that I need to make 0. So what I do? 3 times row 2, add in row 3. 1, 2, negative 1, 0, 1, 0, 1, negative 4 over 3, negative 3, 0. So 3 multiply 1 is 3, minus 3 is a 0. When I multiply 3 with minus 4 over 3, 3 cancel, minus 4 plus 2 is minus 2. And I multiply this by 3. 3 multiply negative 3 is a negative 9. Negative 9 plus 6 is plus 3 is a negative 6. Now we can make leading coefficient rho 3 equal to 1, negative 1 over 2 R3. One, two, negative 1, 0. 0, 1, negative 4 over 3, negative 3. 0, 0, 1, and 3. Now this is echelon form, row echelon form. If you like, you can stop here. If question is not asking you to go up to reduce echelon form, you can stop here. So from here, what value of x you get directly?
x3 equal 3.
x3
Equal to 3. Then from second row we get x2 minus
Over
4 over
3x.
3x3 equal to minus 3. Now we put value of x3. So x2 is equal to negative 3 and plus 4 over 3 times 3 is 3. So plus 4. 1. x1 minus 2 x2 minus x3 equal 0. So x1 is equal to 2x2. Oh, x1 plus 2x2. Why I'm writing minus? So x1 is equal to negative 2x2. Negative 2 times 1 is a negative 2. And plus x3 on the other side. x3 is a 3, so plus 3 equal to 1. So we have x1 is 1, x2 is 1, x3 is a negative 3. This is a solution.
x3 is 3.
Oh, not negative 3. x3 is a 3. So does this satisfy equation? Let me write any one of these equation. Maybe first equation is x1. First equation. What will be first equation? x1 plus 2x2 minus x3. Do we get a 9 here with these numbers? Oh, sorry, not 9. It is 0. So 1 plus 2, 3 minus 3 equal to 0, correct. And if let me say if I write 2x2 plus 2x1 plus x2 minus 2x3. Do we get 9? No.
No.
I think
No.
x1 should be 2.
Plus 2x3.
We have done a calculation mistake.
x1 is
No, doctor.
should be 2.
Plus 2x3, not minus 2x3.
Sorry?
Plus 2x3, not minus.
Yeah, it's plus.
Oh, plus. Here is my mistake. 2 times 3 is a 6. Plus 1, 7 plus 2, 9. So that's it. This is question number 6. So we have 113 as a solution. Yes.
Doctor, do we must substitute in the original equation to make sure?
To make sure. To make sure. Now, it's better to put in all, because maybe you get by chance, maybe you get some solution which satisfy 2 but not the third one. You know, we have here so many plus, minus, multiply. So many calculations here. And there is a big chance that we may do some kind of plus minus mistake, and that may lead to a wrong solution. So it's better to check maybe quickly, you don't need to write it, just quickly. Third equation is x1, yani 1, minus x2, yani minus 2, plus what? 3. X1 minus x2 plus x3. What do we get? 1 minus 1 plus 3 equal to 3. Yeah, so quickly you can check it. Okay, now I did one example where we have 3 variables, 2 equations, and we get infinitely many solutions by choosing one of the variable as a free variable. Now, it may happen that the system has no solution. Let me show you one, say, question which has no solution. This is question number 14. Let me write equations. Is better for the sake of completeness. X1 minus 2x2 plus x3. X1 minus 2x plus x3 is equal to 2. 3x1 minus x2 plus 2x3 is equal to 5. 2x1 plus x2 plus x3 is equal to 1. So the augmented matrix is 1, minus 2, 1, and 2. And then 3, minus 1, 2, and 5. 2, 1, 1, 1. 2, 1, 1, 1, 3 minus 1, 2, 5. And 1 minus 2, 1, 2. Now, luckily, we have leading coefficient in first row 1 and then negative 3 time R1 add in R2, negative 2 time R1 add in R3. So 1, negative 2, 1, 2, negative 3, positive 3, 0. Negative 2, negative 3, 6, 6 minus 1, 5. Negative 3 plus 2, negative 1. Negative 3 times 2 is negative 6 plus 1, negative 1. Now multiply with negative 2, positive 2, 0. Negative, negative, positive 4 and 5. And negative 2 plus 1, negative 1. Multiply 2 by negative 2, negative 4 plus 1. Negative 4 plus 1, negative 3. Now, you see that on the left hand side, we have 5, negative 1, 5, negative 1, but on the other side, we have different numbers. Okay, before I change to leading coefficient in row 2 to 1, let me apply negative row 2, add in row 3. Because I see here no solution. 1, negative 2, 1, and 2. 0, 5, negative 1, negative 1. 0, negative 5, positive 5, 0, 0. Negative multiply negative 1 is positive 1,
minus
and then negative 2. So it is not possible. If we convert the last row into equations, we get 0x1 plus 0x2 plus 0x3 equal to negative 2. There is no value of x1, x2, or x3 which can satisfy this equation. So whenever this happens, it is inconsistent system. So we say that not possible. So no solution. So there can be a solution. There can be no solution. Okay.
Doctor, is there another way to have a solution? Another step?
No, when this thing happen, then there is no solution. This system has no solution. Some other question may have solution, but this question, these three equations, they do not have some values of x1, x2, x3 which satisfy all three equations. Maslan, if you another situation here is question number 16. Question number 16 is x1 minus x2 minus 2x3 is equal to -1. Minus 3x1 minus 2x2 plus x3 is equal to -7. And third equation is 2x1 plus 3x2 plus x3 equal to 8. So the augmented matrix is 1, -1, -2. You can save your one row operation. Okay, suppose equation 1 is given as equation 3. So still you can write it as a first equation, because what is first equation, what is second equation, that doesn't matter here. So by chance here first equation has 1, -1, -2 equal to -1. Second equation, whatever you like, you can say, okay, this is second equation. So let me say -3, -2, 1, and -7. 2, 3, 1, 8. So we have 3 times row 1, add in row 2. -2 times row 1, add in row 3. We choose this 1, -1, -2, -1. 3 minus 3, 0. -3 plus 2. Sorry.
Minus.
-3 minus 2 minus 5. -6 plus 1 minus 5. -3 minus 7. Minus
4.
-3.
Oh, okay.
-7. -3 and -7. Okay, then third is multiply by -2. So -2 positive 2 is 0. -1 multiply -2 is 2. 2 plus 3 is 5. -2 times -2 is 4 plus 1 is 5. Negative, and it is equal to 10. So you can see that row 2 and row 3 are exactly same. And if you want, you can do one row operation, that row 2 add in row 3 simply. And when we do this, we can see that -1 minus 2 equal to -1. 0, -5, -5, -10, 0, 0, 0, and 0. Now, if you like, you can do -1 over 5 R2. You can do it before even, no problem. and then make third row equal to 0, 0, 0. So this choice of row operations is somehow depend on you also. Whatever you like, 1, -1, -2, -1, 0, -5 over -5 is 1, 1 and 2, 0, 0, 0, 0. Now the equations, we have non-zero equations are 2 only. And this is a situation when we have a free variable. Now, third equation is 0 equal to 0. That is always true. Second row will give you x2 plus x3 is equal to 2. OK. So this is a situation when we have one free variable, because non-zero rows 2, variables 3. So which variable you want to choose as a free variable, Shabab? X1, X2 or X3? Which one? X3. So you say let X3 is equal to T. Then the second row X2 plus X3 equal to 2 give you X2 is equal to 2 minus X3. X3 is T, so 2 minus T. And first row give you X1 minus X2 minus 2X3 equal to -1. So X1 is equal to -1 plus X2 plus 2X3 is equal to -1 plus X2, yani plus 2 minus T plus 2X3 plus 2T is equal to -1 plus 2 is 1 and 2T minus T is T. So 1 plus T. So the solutions are 1 plus T, 2 minus T and T. And there are infinitely many solutions. You can take some value of T and verify.
Doctor?
Yes.
Can't we add one more step and say R1 plus R2?
If you want to reduce it, into reduced echelon form, you can say that R2 add in R1. This is what you want?
R1 plus R2.
No. Where will be the change?
To R2. Will be 0, 0.
Then the first 0 will become non-zero.
Yes, yes.
We need to have it 0. Yeah, you can say add R2 in R1. And if you do that, you are using R2 and changing R1, because the change will be here. So 0, 1, 1, 2, 0, 0, 0, 0, 1, 0 plus 1 is 1, 1 minus 1 is 0, and -1 and 1. You can do this.
But still nothing change.
Nothing will change. Nothing will change. You make it into echelon form or reduce echelon form. Now here you can put. Yes?
Even I tried more and more, nothing will be changed, right?
No, the final solution will not change. So there are infinitely many solutions. Let us check one solution with T equal to 1. So 2, 1 and 1. Does this satisfy this equation? X1 minus X2 minus 2X3, X1, 2 minus 1 minus 2. So what do you get? -1? Yeah, correct. It does satisfy equation 1. Similarly, you can verify that it also satisfies third equation, second equation. So here we have infinitely many solutions. Okay, so here I have done some of the questions. Now you can still, there are many more questions in the exercise. You can solve more questions at home. Now let me go to the section 8.3, rank of a matrix. Do you see this now, rank of a matrix?
Yes.
Yes, yes.
Now, the same thing we are doing, but um, from same thing mean from elementary row operations, we are getting some new information. First of all is what is definition or tarif of a rank of a matrix. If you have m by n matrix A, the rank of A is denoted by rank bracket A is the maximum number of linearly independent row vectors in A. Maximum number of linearly independent vectors. Now, here, how to get this rank? This is the definition. Apply elementary row operations on the matrix A and obtain an equivalent matrix B. Like in the previous exercise, let me show you that. Come on. You know, at the end, for example, if we say the starting matrix is A, then the ending matrix, last matrix, we can say it is B. And these two matrices are equivalent. So this is what is said here. Apply elementary row operations on the matrix A and obtain an equivalent matrix B, which is in row echelon form. So you convert the matrix A into row echelon form, and you can give that new matrix a name B. Not a problem. Then in the matrix B, the number of non-zero rows is called rank of A. Yani rank of a matrix is the number of non-zero rows in its echelon form. Okay. For example, can I hope you remember what was the last matrix in the previous question 8.2. How many rows were 0 rows? Last one, 1, 0. So what can you say about rank of the matrix?
It's 2.
2. Now here I am taking another example. A is this one. When I apply these two row operations, I get row 2 and row 3 equal to 0 rows. So the rank of matrix is 1. Only one non-zero row. Now, if we have so this is just a matrix. If we have a linear system, AX equal to B, then a linear system of equations AX equal to B is consistent. You know what does mean consistent? It has one or many solutions. One or infinitely many, not one or two, one or three, no, one or infinitely many. A linear system of equations is consistent and it has a solution if and only if rank of the coefficient matrix A is the same as rank of the augmented matrix AB. To explain this, here I'm showing you this example. X1 plus X2 equal to 1, 4X1 minus X2 equal to negative 6, 2X1 minus 3X2 equal to 8. When I put in the matrix form, I apply row operations, I get a matrix in the echelon form, and that is telling me rank is 2. Now I consider the augmented matrix. Now I consider what? The augmented matrix. And I included the right hand side numbers. After that, when I apply row operations, I see what? What do you see here? What can you tell about the system here?
We don't see the last row.
Sorry?
I didn't
Okay.
see that. Okay.
Now what can
no
you say
solution.
about no solution? What is rank of this augmented matrix?
3.
Of course, it is 3. Because now we have 16 as a non-zero number in the last row. So rank of A slash B, A, B. How do we say this? A line B? Okay. So whatever it is, rank of this augmented matrix AB is 3 and rank of the coefficient matrix is 2. They are not equal. So this theorem is not satisfied. This theorem says a linear system is consistent and it has a solution if and only if rank of the coefficient matrix is the same as rank of augmented matrix. So if the rank of coefficient matrix is equal to rank of augmented matrix, then there is a solution. If not, there is no solution. And you can see here there is no solution because rank of A is not equal to rank of augmented matrix AB. Okay. Now, whatever we have learned before, it is now shown by this diagram flow chart. Suppose we have AX equal to 0, yani a homogeneous system, and this system is always consistent. Why always consistent? Has trivial solution. What trivial solution? X1 equal to X2 equal to Xn all equal to 0. So always consistent, yani always has a 0 solution, but we are not interested in that. Anyway, it depends on system. Now, when it is consistent, then we have two possibilities. Number one, we have a unique solution, yani one solution, only one solution if rank of A is equal to n, yani the number of variables or number of equations, n. And rank of A is less than n. If rank of A, now n is a number of variables. N is representing here n number of variables. And here on the right hand side, you can see R. Here R is representing number of equations. I don't know why they are using R. They were using M before, and now all of a sudden they change it to R. So n minus R will be arbitrary parameters, or we can say free variables. Arbitrary parameter mean free variables. So we can have one solution or infinitely many solutions. It depends on rank of the matrix A. Now in this case, we have no augmented matrix because the right hand side is 0. Now you come down for a non-homogeneous system, AX equal to B, where B is not 0. Now for a non-homogeneous, we have two choices. Maybe rank of A and rank of AB is equal. Rank of A is equal to rank of A augmented matrix AB. In this case, the system is consistent according to theorem. And when rank of A is less than rank of augmented matrix AB, then inconsistent, as you have seen in the previous example. Rank of A was 2, rank of AB was 3, so we saw that there is no solution. Now, when we have a consistent system, we have two possibilities. Maybe there is one solution, maybe there are infinitely many solutions. And same thing is here, like for the homogeneous case, when rank of A is equal to number of elements, number of variables, then unique solution. And if rank of A is less than n, then infinitely many solutions, and n minus r will be free variables. So
Doctor,
this is the whole, say, story. Yep.
R here is the number of the equation that are linearly independent, or all equations that give
No,
me.
no. All equations.
Okay.
R is number of equations. Okay. So we have this one. Now after this, let me open the book and do some questions from exercise.
Doctor, what does augmented matrix mean?
Augmented matrix is matrix A and matrix on the right hand side B. We put them together without any operation. We simply put them together. We simply put these two matrices together like you put a table and a chair together. Like that. We simply put these two matrices together and we call it augmented matrix. Okay, I'm going to section 8.3. I have 11 minutes left. I can do some questions from the exercise. Here in exercise, it is saying that find rank of the matrices from question number 1 up to question number 10. It says use theorem 8.3.1, and what is 8.3.1 theorem? Rank a number of non-zero rows. So which question should I take? I don't know. Maybe let me take question number 3. So here now we are doing exercise. Come on. So this exercise is just rank. And first question, let me post it here. So it is number 3. You need to find rank of this matrix. Find rank. Now solution starts here. What you want to do?
Change 1 and 3.
I think it will be complicated.
Yeah, okay, no problem.
Doctor, we
Divide row 1 by 2.
Doctor, R1 plus 3R3. Or 2R. R1 plus 2R3.
So we can do this also. 1/2 row 1 plus row 3, because we just need to see how many say non-zero rows are there. So 1/2 row 1 plus row 3, and negative 3 times row 1 add in row 2. Maybe we can change this 2 to 1 at the end if we need to solve a system, but if you are finding a rank, we can take the same thing. So multiply by -3. So -3 times 2 is -6 plus 6 is 0. -3 plus 3 is 0. 0. Was this the same example I show you here for the rank? Oh yeah, this is the same question number 3 I did here before. You see it now?
Yes.
Yes.
Yes. So we are done with this one. This question is done, that we need
Doctor,
to apply row operations.
can you solve number 7?
I will, no problem. So what you are saying is to solve number 7. Let me flip this, because then I can see both. Okay, let me take its snapshot and put it there. Okay, let's apply row operations. What row operation you can apply? -3 times row 1 add in row 2. -7 times row 1 add in row 3. -4 times row 1 add in row 4. So 1, -2. -3, +3 is 0. And negative, positive. 3 to 6, -6 is 0. Okay. And -7 plus 7 is 0. Negative, positive. 7 multiplied 2 is 14. 14 minus 1 is 13. -4 plus 4 is 0. Negative, positive. 4 to 8. 8 plus 5, 13. And when you apply another row operation, yani negative times row 3 add in row 4. 1, -2. 0, 0. 0, 13. 0, 0. So what is the rank of the matrix?
2.
Equal to 2. Now here, if we are solving a linear system with these coefficients, then we can interchange row 2 and row 3, and then divide row 2 by 13, make it 1, and then solve equations. But here we are not doing that. We are simply finding the rank. So rank is 2 here. This is what you need to do to find rank. Now questions in this exercise, question number 1 up to question number 10, you are seeing in your book, they are to find the rank. Then determine whether the given set of vectors is linearly independent or linearly dependent.
Doctor,
Same
don't
thing.
we consider about the right-hand side?
Sorry?
Don't we consider the right-hand side if it's 0 or not?
No. Rank. Here, this is the rank of the matrix. This is not a system. Is it what you are thinking?
Yes.
No, so far we are looking for matrices only. And then question number 11, 12, 13, 14. I think it is better for you if you also open, whenever you have lecture class, you open your book in parallel. And when we go to exercise, you can tell me what question you want me to solve. So here I'm seeing here on my screen that question number 11 up to 14, they are to see if the vectors are linearly independent.
Can you solve 12?
Okay. Question number 12. Let me take its a snapshot, take it over there. I have only time for one question. So let me just paste it here. Okay. Oh no. All right. The solution starts here. What we will do, we will make a matrix of the coefficients. 2. Let me put U2 first to save one of my step. 1, -1, and 4. 2, 6, and 3. Oh, there are 4 vectors. So I need to have 4 rows. And I put 1, -1, 4, 2, 6, 3, and then 3, 2, 1, 2, 5, and 4. -2, row 1, add in row 2. -3 times row 1, add in row 3. -2 times row 1, add in row 4. One, -1, and 4. So row 1, -2, +2, 0. 2 plus 6, 8. -8 plus 3, -8 plus 3, -5. -3, +3, 0. 3 plus 2, 5. -12 plus 1, -12 plus 1, -10. And then -2, +2, 0. -1 times -2, 2 plus 5, 7. -8 plus 4, -8 plus 4 is -4.
Doctor,
Oh, yeah,
I think it's -11, not -10.
-12 plus 1, -11. You are absolutely right. Now, you cannot avoid quotients. You cannot avoid quotients. I have time 10:20. You apply more row operations and try to make the numbers below 8 equal to 0. Then continue further and see if you get rank of this say matrix equal to how many rows. If you get a 0 row, if you get a 0 row, then they are linearly dependent. Otherwise, they are linearly independent. Okay, so try to complete this. Let me download the attendance sheet. So here I suggest you to complete this and see what matrix you get.
Doctor, so the matrix above is linearly dependent because we have 2 rows are 0.
2 rows are 0. So if you have 4 vectors, I'm reading like 1, -2, second vector 3, -6, third vector 4, 7, -1, then next vector 4, 5. So they are linearly dependent if they represent some vectors. That's good.
So this is dependent or independent? I didn't get.
Dependent.
Okay.
Doctor, that means if one of factors are dependent, that means the whole matrix are dependent?
These vectors are linearly dependent if we get a 0 row.
Okay.
If all the rows are non-zero, yani there is some non-zero number in all rows, then they are linearly independent. Okay.
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 And You can complete this. Of course, you need to apply some row operations, and then at the end, you will see that they are linearly independent or dependent. And again, I'm telling you, if you get a 0 row, then linearly dependent. If all rows are non-zero, if all rows are non-zero, then linearly independent. Okay, so now it is time. If you have any question, I'm here to answer. If you have no question, you can leave.
Doctor,